Today is Unit 7, Day 1. It's Tuesday, February 5th. The aim is, how do we identify the key components of a quadratic equation from its graph? Press pause now to complete the do now. Press play when you're ready to go over it. So this equation has a slope of positive 3. So we give the denominator 1, and then we move up 3, right 1. The y-intercept is negative 1. So we plot on the y-axis, and then we move up 3, right 1. Can't move any more, we go down in the opposite direction, down 3, left 1. That's not very good. Make sure you have your straight edge with you so that you can draw a straight line. And this next one looks similar, but the slope here is negative 3. So that means we'll move down and to the right. The y-intercept is negative 1. So same y-intercept, but now we're going to move down 3, right 1. So our line's going in the opposite direction. We can go back the other way to get more points. So the line will be going up when the slope is positive. This blue line, the only difference between the blue and the green is that the slope was positive in the blue, and that line is going up. And the line will be going down when the slope is negative. So to match this up, we can see that a linear function is the most basic kind. Nothing weird, nothing strange is happening to the x. It's just a regular x with a normal exponent of 1, where we don't even see the exponent. So that would be that first equation right there. Quadratic, that tells us that we have an x squared, and that that's the highest exponent we have on the x. Absolute value function, well, that's easy to spot because we have the absolute value symbols right there. And then finally, for the exponential function, it's left over, but you know it's exponential because x is the exponent. X is the exponent, so it's exponential. Okay, so for the mini lesson, let's just remember some old news. With a linear equation, we have a y here, and we have an x, and then it's m and b that change around sometimes. Those values tell us everything about the line. We saw in the do now example that it tells us exactly what the graph looks like. We're going to start looking at quadratic equations today, and they have a different form. So we just saw in the matching activity that the quadratic always has this x squared. The general form that we have is this y equals ax squared plus bx plus c. So those are the values, a, b, and c, that change. It doesn't tell us exactly what the graph looks like right away, but it certainly does have some impact on the graph. Let's explore quadratic equations and their graphs and important pieces of them. So take a look at this first one. We already know how to use the graphing calculator to get the table. So take your graphing calculator, go to y equals, and we will type this in. So if you have something there, just clear out. And we're going to go to, so if you have to press y equals, it's right there. And then to type x, it's this button right here. So x squared plus 2x minus 3. if you press the graph button, you'll get a preview of what your graph should look like. But we do not want to copy from there. Our points won't be exactly where they should be, so we need to get to the table. So press second graph, and that way we get the table. We want this bottom number and this top number to match up perfectly. Right now they don't. If we play around with our arrows and we move, now that top number and bottom number match. So the 5 matches with 5. That's the portion of the table that we're going to copy. So let's go back to the handout and copy that down. And we can plot those points on the graph. Now, just a reminder, when we connect these points, it's a smooth U. Do not use a straight edge here. It's a very smooth curve, so you don't want to have any jagged lines. Start at the bottom to make a nice U, and then continue up in both directions. And put some arrows in here. So now we're going to talk about some vocabulary that's important with these quadratics. And it's not something that we got into before when we were just graphing. Now we're really going to pick these pieces apart. So now, the first thing that we're going to talk about are the roots or the zeros. So if you think about a plant, and you think about a plant growing out of the ground, the roots are what anchor the plant to the ground. So you can almost think about the roots of this quadratic as the points that connect it to the ground. And we can see the roots are here, connecting it to the x-axis. Because those points intersect the x-axis, we're going to call them the x-intercepts. Just like we used to talk about the y-intercept, now we're looking at the x-axis, so it's the x-intercepts. Where the parabola intersects the x-axis. Remember, parabola is the name of the shape of the curve. And so we can go ahead and label these guys as our roots or our zeros. There are a lot of different names for these. Roots, zeros, x-intercepts. Now, if we think about the next one, that's the vertex. That's the point that's all by itself. It's by itself, and there's no point that matches up to it. If you notice, right here, it looks like this curve's going down, and right here it turns back around and starts to go up. So the nickname for the vertex is the turning point. In this case, the vertex is at the bottom. It's the lowest point on the graph. So because it's at the bottom and it's the lowest, it's called a minimum. Sometimes it'll be at the top and it'll be a maximum. So the turning point is always either the minimum or the maximum. So let's go ahead and label that there. Before we move on to the next one, I just want to show you something. So go back to the table. 5 matches up with 5. Draw this in yourself too. 0 matches up with 0. 3 matches up with -3 with -3. And this point, -1, -4, that's the point that's by itself. That's the vertex. So actually, we can spot the vertex from the table. Not only that, if you think about the coordinates of this root right here, that's the point 1, 0. And this is the point -3, 0. So notice how the y values are always 0. That's where it gets its name, and we can spot that on the table also. We don't care about that 0. This 0 on the x-axis, that doesn't matter. It's these y values of 0 that tell us the roots. So actually, the table itself gives us all the information. We can look at the graph to get it, but we could also look at the table. It's a good way to check yourself. Now, for the last definition here, the last piece of vocabulary, axis of symmetry. Think about what the word symmetry means, or symmetrical. Like a butterfly is symmetrical. A butterfly is symmetrical because you could literally draw a line down the center of the butterfly, and it would be a perfect mirror image. That line that you can draw down the center, that vertical line, that's called the axis of symmetry. So if we go back over to our graph here, right here, that's kind of the middle point. There's a vertical line we could draw that would cut this in half. And in fact, that would go on forever and ever. Now, that is not something that we automatically graph on this graph, but it is something that we should be aware of that exists. It's invisible, the axis of symmetry. So that's a vertical line that cuts the parabola in half. Okay, so let's answer some questions about this. I'll be going back and forth between the graph and the questions. So this is actually asking us, what are the roots or the zeros? We already sort of did that work when we wrote the coordinates of the point. So let's rewrite them. It's the whole thing, -3, 0, and 1, 0. Now, the zeros, there's another way to write this same information. We know, if we're talking about zeros, we know that this number here is always 0. So it's kind of redundant to write it. So we could just look at these x values, -3 and 1, and list them. Those are the zeros. Those give us a y value of 0. There's another way to write it. We could write it as a list with the braces and list it out like that. The coordinates of the vertex, we already saw that the vertex is this point right here. So now we just have to say the coordinates. We see it in the table too. That's -1, 4. Now for the equation of the axis of symmetry, vertical lines, those have the equation x equals. And if you think about it, x is always going to be, we're always going to be moving for any of these points on here. We're moving to the left one, so that's -1. Then -1, anything, up or down. So x equals -1 is the equation for the axis of symmetry. But notice how this -1 is the same thing as the x value of the vertex. So you can make a note to yourself here on the side that x equals the x coordinate of the vertex. Because if you look at the graph, you see that this axis of symmetry cuts right through this point, which is the vertex. So it would make sense that they'd have the same x value. Now this is weird, the values of A, B, and C. Remember that y equals, that's the form for the quadratic, and our function was y equals x squared plus 2x minus 3. So it's not that easy to see, but there's a 1 that we know is being multiplied there, so A equals 1. And there's a 2 plus 2, so that's the B. And finally, C is negative 3. Now, is the parabola facing up or down? That thing's facing up. It looks like a happy face. So, it's facing up. If you want to make a note to yourself, it looks like a happy face is up, and it looks like a frown, then it's down. So because our vertex is at the bottom, it's the lowest, we say that it's a minimum. So next one, on your calculator, type in, you got to go into y equals again, clear this out, and start with the negative sign. You need to type in negative, otherwise it's not going to work. If you put a subtraction sign, you'll get the wrong stuff, or maybe you'll get an error. So we can take a graph, we can look at the graph, it's a preview, but what we really want is the table. That portion of the table, that's not what we want. We want the top number and the bottom number to match up. So we're going to have to scroll down a little bit in order to get that to match up. Not there yet. There we go. Now negative 5 matches with negative 5. And let's plot this. And then we put x. All right. So now, the roots are the zeros. We can see them intersecting the x-axis. So those are the roots of the zeros. We can also see them here, where we have each of those guys are 0. It doesn't have to do with any particular order or location. We are looking at the x-axis. That's what we care about. Or we could just say that the zeros are those x values, negative 1 and 3. And the coordinate to the vertex is that point in the middle. And we can also see it from the table. If we sort of single everything out, we're left with that by itself. That's the vertex. Now for the equation of the axis of symmetry, that's just going to cut this thing right in half. That x value is 1. We can see here, for the vertex, x is 1, so that's the equation of our axis of symmetry for that vertical line. For A, B, and C. So we know And our equation was negative x squared plus 2x plus 3. So that's a negative 1. B equals 2, we see that right there. And C is 3. This parabola looks like a frown, so it's facing down. And the vertex is on top, so that point is the location of a maximum because it's on top. So for E, F, G, and H, we're just going to be talking about these, and you can write these responses down. But we said that the graph in example 1 was facing up, and this one's facing down. Now, the equations are different. Notice how in that one, the first one we did, B equals 2, that's the same. So B equals 2 of these. But it looks like A and C are different. So there, A was positive 1, C was negative 3, and now we have the other way around with the negatives and positives. So maybe you could come up with some idea of when you think the parabola will be facing up, when you think it will be facing down. Take a moment, pause this, and write a response to G and H. And we'll eventually discover if you're right. Maybe you have the right idea. All right. Try this one completely on your own from start to finish. Press pause, and when you're done, press play so that you can go over it. So the table that we want, where our top and our bottom value match, is this. So we see we have a top and bottom value match. We can see we have our zeros and our vertex. They're easy to spot. The roots are these points touching the x-axis. It's always on the x-axis. So we can write the coordinates there. We can also see them here. So those are our roots. We can just list the x values if we want. So this is always x, y. So the x values are just 0 and 2. Vertex is this point right here. It's also this point that's by itself in the table. The axis of symmetry, we can draw that vertical line, and we see that that vertical line has an equation of x equals 1. So now for A, B, and C, we write this in. Well, A equals negative 1. B equals 2. But look, C is not even there. So that's like we added on a 0. It's kind of like when we're graphing lines and you can't see the y-intercept. And you just say that the y-intercept is 0. It's the same kind of thing. This parabola is facing down because it looks like a frown. And because the vertex is on top, it actually is the location of a maximum. Now try this one completely on your own from start to finish. And Press play when you're ready to go over it. So that's kind of ugly. Make sure it's a smooth view down here. So the roots are what's touching the x-axis. Or we could just say the x values, -2 and 0. We see them here. The vertex is that point that's right in the middle. And you can see it on the graph right here. -1, -1. Axis of symmetry cuts right through the center here. And that vertical line has an equation of x equals -1. And now for the values of a, b, and c, we could just match it up with this. We see that a is 1, b is 2, and again, c is 0. Parabola is facing up, and the vertex is a minimum. Now, in this example, the parabola is facing up, but c was 0, so c doesn't have anything to do with it. So go back to, and there, the parabola is facing down, c equals 0, so c doesn't have anything to do with why the parabola faces up or down. If we go back to our original questions about when do you think the parabola will be facing up or down, it doesn't have to do with c, that's for sure. And b has been the same every single time, so it doesn't have to do with b either, so it must be a. So let's take a look at this. Here, a equaled +1, and the parabola is facing up. Here, the parabola is facing down, and a equals -1. It's down again, and a is negative, and here it's up, and a is positive, so it has to do with a. The parabola will be facing up when a is positive, and down when a is. And that will always be the case. It doesn't have to be negative or +1, it just has to be a negative or positive number. So now it's time for your in-class assessment. When you're done, give it to your teacher so that you can get credit for the assessment. And if you're still confused, there's 6-period lunch tutoring. So please speak to me about that, and I'll make sure that I can help you. Have a good day. Thank you.